yesterday a little bit. The inequality stuff. I want to kind of look at this real quick. Okay. When we were talking about inequality yesterday, I made the argument, or I asked the question. You know, if I have right there, it says x is greater than -1. If I read it from the x side first, okay, and that's something to kind of think about. Right this way, x is greater than -1. Would you guys agree that these two things say the same thing? Okay, I'm a fan of writing the variable first. Okay, so if you get a problem that you've worked on, and your variable shows up on the right-hand side, that's fine. But I think it's best then to use what we call a symmetric property to flip it, to put your variable on the left. Okay. Now when I put my variable on the left, it still has to have this symbol, okay, addressing the x and the -1 the same way down here. So if it's an arrow pointing to the -1 down here, it still needs to be pointing to the -1. Does that make sense? Okay. So when I ask this question, what numbers are bigger than -1, or which numbers are greater than -1, the number one answer that I get is 0, 1, 2, and I would agree with those 100%. Okay. But those aren't the first values. Okay. So let's see here. Let's go. I can change the labeling or the font size here so you guys can see it a little bit better on my axes. I think we'll do it. Options, advanced. All right. Okay. All right, so I can't change. I'm trying to change the size of the x-axis here, but I can't do it for some reason. So I apologize for that. But can you read these 0, 1, 2? You can read these numbers down here. Okay. So I want x is greater than -1. Okay. We're looking at that idea right there. Does that make sense? Okay, so this line here, this arrow, this black line, is showing me all the numbers that are bigger than -1. Well, if I think about what that means to me, that means when I zoom in from -1, there should be a point right here where my cursor is. Does it make sense? It's not a whole number. It's like -9.5, or sorry, -0.95, something like that. Okay, or -0.5. or -0.25. Does that make sense? Those values are bigger than -1. Okay. I zoom in even further and kind of see that point maybe right there, or this point right there is to the right of -1. It's bigger than -1. Okay. So when we look at this, guys, and kind of zoom out to get that view. Okay. When I say what numbers are bigger than -1, a lot of people answer as like 0, 1, 2, 3, and those are correct. Those are some of them. The first one is like a -0.999999999 forever. Does that make sense? Okay. And that number itself is very hard to write down. It's not impossible to write down. So how do we address that? And we address all those numbers, being able to write all those answers down using inequalities. Okay. We okay with that idea? Okay. Let's go to change this font size back a little bit. Better. If I ask this thing to generate a new inequality, so now it says x is less than negative 8. So I'm reading it right to left. Now x is less than negative 8. I think that's easy to think about than saying negative 8 is greater than x. Okay? So x is less than negative 8. So I go find negative 8. And then these values over here that are being represented by that arrow are representing all of the x's that are less than negative 8. Does that make sense? It's representing all those infinite number of solutions that would make this statement, x is less than negative 8, true. So I can plug in negative 9 there. I'll plug in negative 9 for that right there. Would you guys agree that negative 8 is greater than negative 9? Okay, so that's why negative 9 has to be added to our solution list. Okay, and all those numbers to the left there are like that. Okay, if I say x is less than or equal to 9. Okay, so we're going to find 9. Put 9 there. Would you agree that those are the numbers that are less than or equal to 9? Okay, now there's one thing that we have to understand, and we'll talk about this in the notes test. This is an open dot. Okay, which means that 9 is not being included, which means that this is really this line here that I'm showing is actually saying x is just less than 9. I need to close that dot in, and that's going to tell me x is less than or equal to 9, and that's where I get, obviously, the correct argument there. Okay, I will put this, I think this is a useful tool here to see if we can generate ultimately an infinite number of kind of questions here. To check to see if we can kind of create the correct inequality. All right, it's just going to be a little bit extra practice if you need that. Okay, so that takes us then to our notes that we were talking about yesterday. So let's get those out, and we'll look at. I don't think we even got to any of these with you guys. So I want to erase some of this real quick. Solution of inequality down here. Okay. So the idea when we talk about inequality, well, let's kind of compare this to what we did with equality. Okay, when we solved an equation, how many solutions do we have to equations? What was the primary amount of solutions we had? And when I give you, like, let's say this equation right here, this red one, how many solutions, how many values of x are you going to find when you go through that problem? If I add x to both sides, I'm going to get 3x, right? Subtract 3 from both sides, I get 4 over here. 3x equals 4. I'll divide both sides by 3 and get x to equal 4/3, right? X is 4/3. How many solutions do I have for x? Just had one, right? 4/3. Does that make sense? Now we can have no solutions. We're going to have infinite solutions as well. Okay, we talked about that a little bit in chapter 2. But predominantly, when we deal with an equation, we get one solution. Okay, but when you deal with an inequality, you get infinite solutions. Okay, you can't physically write down an infinite number of things. You would die doing that. Okay, so we got to have a technique for doing that, and then we're going to investigate our technique here. Okay, if you remember back to equations, the first thing we did with equations, if I had like 2x, I'll just write this as an equation. If I had 2x plus 1 equals negative 3, I would ask you, does x equaling, like, say, 4, does that make this a true statement? And you would plug 4 in. And you get 8 plus 1, which would be 9. And we ask yourself, does 9 equal negative 3? And you'd say no, which means that x equaling 4 is not the answer to that equation, right? Does that make sense? Yeah. Okay. The only time that I would get an answer to that equation is when I would get a statement that says negative 3 equals negative 3. Does that make sense? And then that x value that did that would be my solution. So that does not satisfy the equation. Well, now we're going to do the same exact thing, but we're going to deal with inequalities. Okay? So right here, as I work with this inequality, it's 2x plus 1 is greater than negative 3. They're asking you if this is your x value, the heck? You jumped me to last period's notes. Okay. So if this is your x value, okay, does that satisfy, does it make this inequality true? Okay. So we're asking, is this inequality, put a question mark there, is this true when x is -3? So you're going to substitute. You go 2 times -3 plus 1. We're going to ask ourselves, is that greater than -3? So what's -3 times 2? So when I do the order of operations stuff, that does give me -5 on the left, right? And now we have to ask ourselves, when it was an equation, it was just, well, is the left-hand side the same as the right-hand side? And that was easy to answer, right? Now we have to compare these numbers. We ask the question, is -5 greater than -3? The answer to that is no. Okay? So -3, this answer, that value right there for x, is not a solution. -3 is not a solution to the original inequality. Okay? One thing I need you guys to understand, and this is a very big issue, okay? When we're comparing numbers, this only happens when comparing negative numbers. Okay? If I gave you a positive number and a negative number, which one's always going to be less? If I give you one positive number and one negative number, which one is always the one that is less? The negative one, right? If I give you two positive numbers, isn't the smallest one always the less one? Does that make sense? But when it's two negatives, a lot of people want to use, well, this is a 5 and that's a 3. 3 is less than 5. 5 is greater than 3. So they say, well, yeah, this is a true statement. Because they just look at the 5 and they just look at the 3. You got to realize that on a number line, if there's 0, there's -3, there's -5. When we're asking the question of being less than or greater than, and that type of stuff, we're comparing those two numbers. Orange one to the purple one. Which one's to the left? Furthest to the left? Orange or purple? Orange, right? So that means that's the smallest one. The thing on a number line that is furthest to the left is the smallest thing. Okay? Even though the 5 is a bigger numerical amount than 3, right? Okay? But it's negative. So that number line is kind of, we get used to comparing on the positive side of the number line, and then we want to take that, what we've learned there, and transfer it to the other side of the number line. You can't do that in this type of situation. You have to understand that -5 is furthest left. Is everyone okay with that? I think that that's maybe an obvious thing, but every year when I teach this stuff in geometry and we work with this in geometry, I have people that struggle with that. So I want to make sure that we're talking about that in Algebra 1. Okay? Okay, so part B here says try -1. So I get 2x plus 1 is greater than -3. That's what I'm choosing this to be my x value, right? That is my x value. Remember, we're asking if that is true. Okay, so I maybe got kind of a question mark on top of that symbol there. What's 2 times -1? -2. And then you added your 1, right? And when I add that 1, what do I get there? -1 is greater than -3, right? Is that true or false? Is -1 bigger? Good, that's true. Okay? So we have the situation, if I'm looking at this on another line, -3 would be there, -1 would be there, obviously 0 is there. Now we've got that red one, a really big red dot, and we got the orange one, okay? But the orange one is further to the left, right? And if we look at our true statement here, down at -1 is greater than -3, could I say -3 is less than -1 as well? Can I read that from the right to the left? Yeah. No. Yes, yeah, I can. The -3 is less than -1. Yeah. So negative 1 is greater. This is like saying, let's say, I think yesterday I said, Lindsay was older than Cameron, right? Can I say Cameron is younger than Lindsay and still say the same conclusion, arrive at the same conclusion? So that's this idea here. Negative 1 is greater than negative 3, but negative 3 at the same time then has to be less than negative 1. You can read these left to right or right to left. Okay? I like to look at them as, when I read it as negative 1 is greater than negative 3, so negative 1 they're saying has to be to the right of negative 3. Is that true? Negative 1 to the right of negative 3? Yeah. Okay? So when they're talking about something that's greater than, we're placing it to the right of the other thing. When it says something is less than, we're placing it to the left of the other thing. Okay? I think if you can kind of tie those two ideas together, answering questions like these hopefully isn't an extreme task, isn't a difficult task. Okay? One that kind of throws people off, though, is something like this. And this is the idea that if I plug in this to be x, so we had 2 times our x plus 1, what was it, less than? Greater than. Is greater than negative 3. I'll go ahead and start evaluating this. It gives me negative 4 plus 1 is greater than negative 3. And now I get negative 3 is greater than negative 3, right? What kind of statement is that? Is negative 3 greater than negative 3? No, that's what it's equal to. Good. Okay? So that's false. So this is not a solution. Okay? Does anybody know what negative 2 actually would be? What would that negative 2, since I got these two numbers here to be actually the same, what does that tell me that this negative 2 actually is? As we look over here, in all these examples we did, we got the end result when we compared, we got different numbers, right? We got negative 1 and negative 3. Here we got negative 5 and negative 3. Here we get negative 3, and we have to compare those. It's the answer to what? No. Go back to what you were saying, because you said it, but then you started to say something else. The answer to if I had 2x plus 1 equals negative 3, if I had that, this here is the answer to that. Does that make sense? Okay? But that's what that means. That's when I get those two numbers to be the same and I have to compare them. That means that negative 2 is kind of the break-even point of where less than and greater than start to come into play. Okay? So, is that okay? Can we do that? Some of your homework questions tonight are going to say, here's an inequality, here's some values to plug in, see if you get a true or false statement. Okay? I'm going to come back down to a couple more of these. I think these are good practice things to do. Okay? We've already seen some of these at the beginning. But this is the product of t and 6. These are maybe a little bit more elaborate than the other ones we did yesterday. But this is the product of t and 6. So, I'm just highlighting what the product means. Multiply. Okay? So when I multiply, and probably 99.9% of the problems that you're going to see, you're going to use two things to multiply, right? So what are those two things they're talking about here? T and 6. Okay? So I'm going to highlight that stuff. I'm going to write the product of t and 6. Okay, so you can do this. You can go like that. Say again? 16. So there's a lot of different ways you can kind of demonstrate that, but 6t is probably the one that's most kind of dominant. Okay? Then I see the phrase is greater than. Okay, so the arrow's going there, right? So 6t is greater than, and then I write my last part 12. Okay? So hopefully this is consistent with what we've talked about at other times doing this type of thing, is that when we move left or right through the phrase, write down what those little sections are telling you. When you write down those little sections, you should then develop we call this an algebraic sentence. You develop that sentence. Yes. Yes. Okay. So, just talking about this one, can I write that one? Even though I wrote it this way, because that's explicitly what this statement's telling me. Could I write this as 12 is less than 16? Yeah, that's fine. That works. Okay? So you go from this side? That works. Okay? V, that's my variable, right? Okay? So what I look for is words like is and are, because those are going to kind of structure like different parts of my statement. So is greater than, and then it says or equal to, right? Like I have that line underneath. So that's greater than or equal to, right? And then say 5. Someone can do? All right. Yep. Okay, so there's some discrepancy in this one. Read the whole statement first before we start. Awesome. Okay. So when I read the whole thing, 3 less than the product of G and T, and I can see the argument where you see the phrase less than, and you automatically want to go inequality, right? So here might be where we see a phrase that gets shared. Less than in this situation means what? Yes, subtraction. Okay. So Flaky told us that this should be, so the product towards multiply, right? So G into the product of G and 2, like we did up here in part A, becomes 2G, right? We got 2G and we got 3. But when I see less than, so everything we've done so far, we kind of read it left to right and then wrote it left to right in our equation, right? Or inequality. But when you see the word less and it is describing subtraction, you have to do it backwards. You have to write the 2G first and then minus 3, right? Okay? And then said is greater than, and then our 15. Lindsay? Your inequality needs to be flipped. Because the 15 is the small, what we're saying up there, if we read that, 2G minus 3 is the bigger thing, right? It's greater than 15. So if you wrote it with 15 first, you have to say 15 is actually less than 2G minus 3. This okay? Come up with, so I'm going to ask you this on your own a little bit. We'll do A and B on your own here. It says write 2 different verbal statements for the following. So in that first one, write down, maybe if I read that left to right, what I could say. And then see if you can adjust that and get something different that really means the same thing. Verbally, English-wise it will look different, but it says the same thing mathematically. So do we have to write 2 for each? 2 for each. 2 for A and B. Okay. In word form, right? Yeah. Oh, then I got it. So I'm going to write, so you want to write a sentence like these up here. So it's working backwards from what we did up here. What we'll come up with for A. 7? Good. N is less than 5. Or 5 is greater than 10, right? Okay. So left to right gives me the first one. n is less than 5. Right to left, 5 is greater than n. You might see either one of those, okay? But they both mathematically mean the same thing, even though they have verbally different words in them, okay? So is that the same thing over here then? Okay, 35 is greater than or equal to W. I think I say W is less than or equal to 35. Okay? Okay. I want to change C a little bit. Let's make it a little bit more.
Yeah, because it says 0, not 9.
Oh, I kept the 0. 0 is a number. You don't like 0? You think 0 is less numbery than 5?
No, my favorite is 1.
Yeah?
The number is well, I don't know. So, yeah.
All right.
That was my aunt's number.
So how do I talk about that?
My aunt.
Okay, so you can write 2b is greater than 0.
Wait, how about 2 and the letter B?
Okay, so then what word are you going to tell me that's making your 2 and your b kind of come together? Product or times, right? Okay, so I'm going to write the product of 2 and b. Apologize for my handwriting being kind of garbage. Is greater than 0, right? Can I flip it and say 0 is less than product of 2 and b, or 2 times b, or something like that. However you want to verbally say multiplication of 2 and b. Now, if you did say so Devin initially said 2b is greater than 0. I don't have a problem. That's right. Okay? But usually you're not going to see, so the purpose of this type of question is so that we can see an inequality and change it into English, because most of the time your task will be able to read an English statement and change it to math. So you'll never see them write like 2b is greater than 0. It's always they're going to have 2 in the product of b, or the product of 2 and b, or something like that. So I just want you to kind of be on the lookout for that type of thing. What kind of numbers are bigger than 0? Well, what is one characteristic? What is one characteristic that is the same for every number that is bigger than 0?
Real numbers.
Well, they are all real numbers, but what? It is too.
0 is not a number.
Yes, it is.
There's 0 people. Yep. No.
That still describes them. Like, if you're a teacher and you walk in and you're like, oh, there's 0,
Okay, but like the 0.
that's a number.
Like some people make 0 sense. Every number bigger than 0 is a blank number.
Real. I told you. Is that it?
Well, no. What kind of numbers are to the left of 0?
Negative.
Negative. So everything that's to the right of 0, positive. Okay. Did you say that? I didn't hear you. Okay. So could I say the product of 2 and b is positive? Does that make sense? That statement there, statement 2, says the exact same statement 1 says, but doesn't use the word greater than, right? When I say is positive, means greater than 0. So you might see something like that. Now, what did you say? You said something about 0 not being...
Oh, is it neutral?
Okay, that's a good way of putting it, okay? If I were to do something like this, if I were to do something like that, and ask you to put equality in there, the product of 2 and b is greater than or equal to 0, I now can't just say it's numbers that are positive, right? Because 0, do we answer whether 0 is positive or negative? And to be honest with you, kind of what she said is that it's neutral. Basically, in a lot of the things that we do later on in math, we really get to choose whether we want 0 to be positive or negative. So what we do is instead of saying that it's neutral, instead of saying it's positive, we just say it's not negative. Does that make sense? A lot of times they say non-negative.
But that means it's
I know, but that's just a math.
I'm telling you to say neutral now.
I like that. I like that idea of calling neutral, but in math tests, you're going to see them say non-negative. Okay. So that when we say non-negative, it means we're including 0 as one of those solutions. So those are some things you won't see it right away, but maybe down the road we'll talk about that again. Okay. Now let's talk about our system for actually expressing our answers. Okay. If I were to ask you to write down all the numbers that are bigger than 1, and I ask you to do that, you can't do it. I ask you to list them with commas. Okay. Take the first number that is big. Here's the thing. You would not even be able to write the first number that's bigger than 1. Okay? Because it's 1 point and then an infinite number of zeros and then a 1 after it. Would you ever get done writing all those zeros?
No.
No.
You die.
Okay? You would die doing that. Okay, so when we want to write the first number bigger than 1, we have to have some different ways of doing this. Okay? And this is all math notation that we've created as humans to express this, okay? And this is what we all agree on. This is what we've been using for years. So I want to kind of make sure that we understand this process. You've seen this before, okay? But it says we use dots to represent the start of an inequality, okay? And they represent the first value that the inequality is addressed. Okay? If the dot is if the inequality includes equality, so it's less than or equal to, or greater than or equal to, then we close the dot. We shade it in. If it's just less than or just greater than, then the dot is left open. Okay? So it gets us 2 words. Okay? And I'm always hesitant, guys, like these are the math words. Do I use those math words with 14, 15-year-old people? I think I should. They're harder words to think about, but I think I should because 1, it builds your vocabulary, but 2, and of course, exam, ACT, uses its vocabulary. Okay? So if I just said, we keep it, or we kick it out, those would be maybe more logical words to be able to describe what we're doing with them. But then, of course, exam and the ACT don't say, which ones do you keep, which ones do you kick out. They say, which ones are inclusive and which ones are exclusive. Okay? Yes, that's exactly so. So, inclusive, okay, if you are included, you're a part of things, right? So something that's inclusive is included, okay? So this is going to provide us, inclusive refers to the equality idea. Let's just say an equality is involved, which is obviously then these symbols. Okay? If we see those symbols inside our problem, okay, we're talking about inclusive, so you keep that value. Okay? That, we call that a closed dot. And that's going to lead us to this picture here. That's our closed dot. That's exactly what those mean. Okay? So equality, so inclusive means equality is involved. We're going to keep the number that shows up in our inequality, we're going to keep that and it's going to be part of our answer. Okay? Algebraically, with the symbols, it's the less than or equal to or the greater than or equal to one. Okay? That means you'll hear me say closed dot, open dot, it's the closed dot. Okay, here's how I remember things. Okay? Well, actually, let's talk about what exclusive means, and then I'll show you how I remember things. Okay, I think it's a good thing to do. Okay? This says exclusive. Okay, so this is kind of like every party that's ever been planned, and Travis has never been invited to. He's been excluded from. Okay? What? All right, so exclusive means you're not included, right? You're left out, okay? So, I'm not going to write this, but equality is not involved. So that's going to lead us to these symbols.
What do you mean I don't get invited to these?
I'm teasing you.
I am the party.
Yeah, I can imagine. Okay, so we've got that. That's either less than or just greater than. Okay, which leads us to what we call an open dot. Okay, which graphically then, as a picture, would just be that. Okay, now here's my question. Which one I gotta close this and start it back up. Hold on.
Oh my Lord.
Come back.
Hey, you still have your old email thing?
I just haven't changed. I'm hopefully getting a new computer here pretty soon. This one's awful. I'm gonna spike it. I'm gonna put it here pretty soon. It's probably 6 or 7 years old. Alright, so if I look at these two things here, okay, look at those sets of symbols. Which one took more ink to draw? Top ones, right? Okay, so then if I look at these symbols, which one took more ink to draw? The top ones. So the ones that take more ink to draw are the ones that go together, right? Does that make sense? Okay. A lot of people get confused. Well, do I use open dot? Do I use closed dot? Well, which one uses more effort, more ink to draw, and they link together? Okay. So let's kind of talk about how we address that down here in some of these examples. Okay. I want to graph n is less than 1. N is less than 1. So what you do is you go to 1 on your number line, right? And you put an open dot. Okay. Now you've got some variety, you got some choices here, and it's just all dependent on how you want to do it. I like to draw above my number line. I don't like to mess my number line up, so I draw above it. If you want to draw on it, you can draw on it. Doesn't matter. Okay. But I'm going to then. So what numbers are less than 1? They go to the left, right? Now you're going to draw an arrow. So here's what this arrow means. Just give me some numbers that are less than 1. Okay. So let me do this. So negative. You said -2. Give me some other ones. -3, -5, -1. 4 of these integers, right? 0. What's some other ones? Okay, 0.5, yeah. But then -0.5. Now we'll go all my halves, right? All is like 1/3 and 2/3 of those. Okay. So if I fill more and more of these in, what's that eventually going to? It's going to look like a solid line, right? That's what this is representing. When I see a solid line right there, it represents an infinite number of kind of points that you were just giving me, numbers that you were just giving me, that work for n is less than 1. That satisfy that inequality. Okay? Now, I want to do this real quick. Would you agree that if I'll just do this on the bottom here. If I draw this blue arrow, that all of those blue points will be the same as all of these purple points?
Yeah.
Okay? So let's put that there. And I'm going to close that one off. I'm going to shade in that blue one, that blue dot. Would you agree that there are an infinite number of purple points, purple values, and an infinite number of blue values that are identical?
Yeah.
So I got a lot of solutions that are the same there, right? Are there any that are different? Yeah, if I ask you to start listing if I ask you to start listing the values of n here, kind of separated by commas, that task that says you can't do because it's impossible, there's an infinite number of them, okay? You would start at like 0.9999 forever, right? Like that? That would be the first number here. Down here in the blue, that number is going to be there. That number is going to be the second number. Because this first number is going to be what? 1. It's going to be 1. Okay? These two, this is still going to have an infinite number of solutions. That's still going to have an infinite number of solutions. But this one's going to have one more. Does that make sense? And because of that one being included in the bottom one, that means my answer is wrong. Does it make sense? Okay? So if you have the right graph, but you have an open dot where it should be a closed dot, or a closed dot and it should be open, you have kicked out or kept one value that you should not have. You got an infinite number of solutions that are right, but you got one that is wrong. And that makes them all wrong. You've all heard the phrase, one bad egg, okay, kind of makes them all bad, right? Okay.
How is it all bad?
You have a rotten egg in your carton, it's going to make them all just gross.
But why? It's just one line.
Okay. Let's do this one. A is greater than or equal to 3. So where do I start? Right here. Where do I start? 3? Start on 3. Is it open or closed dot? Closed dot. So this is. I'm going to just do this so if you wanted to draw on your graph. And now, which direction do I draw my arrow? To the right. That's all I've got to do. Okay. Now, I don't like this one. -2 is less than x. Reading it that way, obviously I'm going to start at -2, right? Okay, so start at -2. Now it's an open dot because it's just left it, right? So now if I look at it this way, I got to think, okay, -2 is less than what numbers? What kind of numbers exist that -2 is less than? -1. Okay, -1. So -2 is less than -1. So,
teachers and students, pardon interruption. Mr. Bainline's 6th and 7th period classes will report to the library today. Again, Mr. Bainline's 6th and 7th period classes should report to the library today for class. Thank you.
okay, so would you guys agree that -2 is less than -1? Is -2 less than 0? Okay, so then all of these numbers should have that criteria, right? My opinion, and this is just me, I want to write it this way first, before I even graph. Because if I write it that way, here's another way to think about this. If you write it where your variable is coming first, and we treat our inequality sign as an arrow, is it pointing to the right direction that you need to graph? Yeah, that's pointing to the right, correct? Graph to the right. This one here, I graph to the right. It's pointing to the right, correct? Which way did I graph here? To the left. It's pointing to the left, right? Now that only holds true if my variable comes first. Does that make sense? If it doesn't come first, I can't use that feature, okay? So, what if I ask you, just real quick, we'll work through these. What if I ask you this? What's that inequality? Okay, so n and 3 have to be used, right? Is it greater than or is it less than? Greater than or equal to. What if I did that one? Good. What if I did close dot and graph that way? Which one is it? It should be, so -4 is further to the left than any of these, right? So I'm going to start with -4, so I should say -4 is less than or equal to my variable. Would it be easier to say n is greater or equal to -4? That's the way I think I could do it. Tomorrow we'll extend on this a little bit. Okay, there is a homework assignment that's going to ask you just to basically do exactly what we did in that handout. Okay, so I think there's 19 questions on it. Should not take you very long. Okay, we'll talk about those tomorrow. Any issues you have with it tomorrow, and then move on to 3-2.